But one of the reasons why we can do this, or how silica fume allows you to use the least amount of cement possible, is you get a replacement factor for it. Because of its size, its fineness, and its chemical reactivity, a small amount of it, in this case we're talking about a 5 to 10% cement replacement, we can get as much as a 4 or 5, 6 times replacement factor, which means if you take out 100 pounds of cement, you can put in roughly 20 pounds of silica fume, 5 to 1 replacement, still get the same strengths. So you've gotten rid of some cement, you've gotten rid of all that water, and you've put a material in that can particle pack and do other things in the concrete, so silica fume really helps them to drive that cement factor lower and lower. This happens to be the Illinois Tollway mix on the Chicago Skyway Bridge that was done 2 years ago, 03. This was actually their starting mix design with high cement factor, 665, some fly ash in there, no silica fume. The water, the gallons of water, this is the volume, absolute volume that mortar occupies. And you see what they ended up doing when they switched over to a high performance concrete. They took out almost 200 pounds of cement. Fly ash is approximately the same. They use silica fume here at 40 pounds. And if you think about it, this 40 pounds, we said that 5 to 1 cement replacement. They took out 200 pounds of cement and put in 40 pounds here. That's 5 to 1, basically. But when they did this, when they lowered the cementitious materials, they're only what, 470, 570, 610. 610 pounds of cementitious materials on this water here is only a 4:0 water cement ratio, almost a 4:1 water cement ratio. We talked about before low water cement ratios, those type things. Normally lower means better. In this case, their old mix was a lot lower water cement ratio than this mix was. In essence, you would think that this mix would not be as good following that technology, but what it shows was you're able to use more aggregate, larger quantities of the good material in your concrete, and strength-wise, well, permeability-wise first, the high performance is a lot less permeable, but strength-wise, we see that the materials catch up at 28 days, that the strengths are basically the same. 3 days, there's a little bit of lag here, but that's actually good for cracking on a bridge deck. When they ran this thing out to 56 days, this strength went up to over 6,500. So they're actually talking about taking more cement out of this because they don't need high strength concrete on a bridge deck. The bridge deck is designed for 4,000 PSI because when the trucks go over it, you want the bridge deck to do this. You want it to bounce and flex. If you make the deck too rigid, then it's not going to flex. So they actually are talking about actually getting rid of more cement out of this to make a lower strength concrete. In the case of Colorado, when they asked their ready mixers to supply a mix design, most people will give you a minimum. I want a 4,000 mix, I want a 5,000 mix, and you have to have a percentage of strength higher than that. In the case of Colorado, they say I want a mix design that's between 5,000 and 6,000 PSI. They cap you. You actually make a mix design that hits that number. They don't test you during the project, but as you submit your mix design for approvals for use on their structure, they make you hit this category. They know that extra strength is easy, but it brings a lot of other bad things to performance if you make too strong a deck. They want it to get as low as permeable as they can, but they also want it to be like regular concrete. From a construction standpoint, we've got a couple things that happen in concrete when we place it. And this is true for all concrete. We have various conditions on the surface of the concrete that cause drying. Sunlight, wind, wind's probably the worst. Humidity, moisture loss. There's always some type of evaporation going on, just right here, right now. In concrete with regular concrete, that's probably a good thing because regular concrete, when you place it, for you guys that have worked with concrete before, you know when you place it, when you strike it off, the first thing that happens is you get a bleed water that comes to the surface. You with me, the guys that work for concrete? What happens is that bleed water, when you place that fresh concrete, the concrete slowly settles, and as it settles, there's excess water in there. We said anything over, I should have stated that, anything over 30 gallons of water is all in there for cracking. You know, you really don't need it to make concrete. Here's our 30 gallons of water in the HPC. We've got an extra 7 gallons of water in there in the old mix. It's just all going to end up in cracking. But that excess water is not needed for hydration either. So what happens is as that concrete settles, this excess water comes to the surface on conventional concrete, and you have to let that water evaporate off the surface before you close the surface and do your final texturing. If you were to just place that concrete, conventional concrete, and close the surface and start curing it and do everything that we saw in that video, you would seal all that bleed water into the concrete and trap it under the surface. That's what a lot of contractors get into trouble with when they do sidewalks and people's driveways. They place concrete and the very next winter the whole top of the concrete is scaled off, and the owner's freaking because he spent $10,000 for a concrete driveway supposed to last for 20 years and it came off in one winter. What happened is the contractor didn't let the bleed water come up and evaporate. He sealed that bleed water in the deck. When the bleed water came up, it couldn't come up and evaporate, so it made for a very weak surface in that concrete. When it went through freeze thaw, bam. You know, when water freezes, it expands 9%. That expansion creates a real lot of tensile force in concrete, and we said concrete's not good at tensile, so it fails in freeze thaw very quickly. That's conventional concrete where there's some bleed water. In the case of high performance concrete, this is where the difference starts to show up, and we probably saw it in some of the videos, is the concrete looked gooey, looked sticky. There wasn't a lot of, no bleed water, you know, because this silica fume has filled up all that void spaces between those baseballs with its BBs. So there's actually no excess capillary pores for the water to migrate to the surface. So on high performance concretes, normally there's no bleed water. Guys have finished concrete their whole life. You know, this is the only way they know how to finish it. You place it, you strike it off, let the bleed water go, we come over, have a cup of coffee, a sandwich, go back an hour later and finish the concrete. Can't do that now. High performance concrete doesn't have bleed water on the surface. So if there's no bleed water on the surface to protect the surface from drying, evaporation doesn't know that. Evaporation's still drying the surface out. Well, once it dries out to a certain point, it cracks. It's called plastic shrinkage cracks. ACI says plastic shrinkage cracks. What is it? By definition, it's cracking that occurs in the surface of fresh concrete soon after it's placed or while it's still plastic. Two key things. Fresh concrete, still plastic. Fresh concrete means when the time the concrete comes down out of the truck, it's fresh, it's movable, it's plastic. It only stays plastic for about 3 hours until it sets. The cement water hydration chemistry makes it start getting hard. So plastic shrinkage cracking only happens in that first 3-hour window. If you can start developing strength in that concrete, you won't have plastic shrinkage cracking because it only happens while it's still stiff and still fresh. So we've got this 3-hour window that we need to protect the concrete from surface drying, but the concrete doesn't bleed, so why do we have to wait for 3 hours? If it doesn't bleed, let's just finish it sooner. Well, let's cure it sooner. If we can cure it in 10 minutes time, then who cares how long plastic shrinkage may be in effect? We have it protected from drying. And that's kind of the way that the finishers have found. This is a chart that's also found in the book looking at finishing parking structures. I'm not going to spend time on this. That'll take you through if you need it. One of the ways to work with contractors on placing high performance concrete with silica fume without bleed water is, you know, you and I, we can stand here and be real didactic. I can tell you information and you can understand it and you can learn. Some people can learn by see-do, like little kids. You show them something or follow me and, you know, and they do it right away. Ride a bike, skiing, anything like that. They're good at see-do. Contractors, you're not going to tell them how to finish concrete and you're not going to show them because they've been doing this for 30, 50 years and they know how to do it, right? Even though they may be doing it the way they do with conventional concrete, not for high performance concrete, how do you get them to learn that? And the way to do that is it's called guided discovery. I'll let you discover what I wanted to tell you in the first place, but I'll just guide you so that you discover what I wanted to tell you. You wouldn't have listened to me if I told you anyhow, so we'll go out and do a test pour for never-evers, people that have never ever worked, contractors that have never ever worked with high performance concrete before. A lot of specifications will actually require a test pour. And the engineer and the architect and the owner will come out and actually stand around and watch the test pour, watch everything happen, you know, watch the contractor do his thing. But what happens is you, as the contractor's doing this test pour, He sees certain things. This is part of his guided discovery. He sees that, hey, this concrete, it's not as slumpy. You know, even though it said it was a 7-inch slump here, this stuff kind of sticks together really well. It's not as slumpy as what it normally should have been. They pick up right away the fact that the concrete doesn't bleed. You strike it off and there's no sheen on the surface of the concrete. So in various conditions, you actually leave part of the test slab out. Let it go bad. It's a test slab. Let them fail. Let them see what happens if you don't do the right thing. Another way for them to learn. So there's part of this test slab. We won't do anything to it. We'll let them finish it the way they would normally finish concrete, just so they can learn themselves what works and what doesn't. Once they learn that this has this plastic shrinkage cracking or potential, then they get into all these elaborate evaporative protection schemes. If you go to American Concrete Institute, they have a whole list of different things you can do, from windbreaks, you know, erecting a windbreak to stop evaporation, wind screens. They go into elaborate fogging, actually fogging, supposedly putting a mist in the surface, trying to create a higher humidity above the bridge deck to stop, this from happening, the evaporation from happening. They go to great stretches of describing, what to do to try and stop evaporation. It's nature. You can't stop evaporation. Deal with it. And that's what we're talking about here. Deal with it. There's no bleed water. If you can place the concrete and you can close the concrete surface, you don't have to worry about trapping any bleed water. Go ahead and do that. You want a final texture? You want a broom texture? You want a tine texture? Fine, put it on and then begin your curing right away, right behind it. If you start curing right away, whether it's that white pigmented curing compound that we saw in the video, or whether it's cotton mats or wet burlap, start putting that on the concrete right away, 10 to 15 minutes after it's been placed. It's already under wet burlap, or it's already under curing compound. It's already done. It's done, guys. Go home. Contractors, leave all your tools on the truck. All your hand tools, all those extra tools for working the concrete and rubbing it and making it look good. They hate when I say this, and ready mixers love it, but the concrete coming down the chute of that truck is as good as it gets. There's nothing the contractor can do to make it any better from a durability standpoint than taking it out of that truck and doing whatever he has to do with it to build the structure and get away from it. The more you work the surface, the lower durable the concrete will be. So what we're talking about here is no delay in final finishing and fast tracking. If you've ever seen them pave a highway, they pave a highway with very stiff concrete. They slip form it. They feed concrete out here. It's like Play-Doh, and the machine walks along and the pavement comes out of the back end of the machine. 200 yards down the road, they'll have a curing train, another bridge that comes across, and they're spraying it with curing compounds. So the finishes are all stretched out within that 200 yards. Well, that's on a normal highway. All we've done for bridge decks and with high performance concrete is we've condensed that train. Instead of being 200 yards long, we've condensed it down to about 30, where the concrete's placed, consolidated, surface is closed, textured, and curing begins, and everybody moves down the pavement all at the same time.